Okay, for the next 5 questions, I think doing it on Excel is going to help to better understand it. So let's get started. Just by looking at this question, first of all, it's like we need to identify what type of problem is this, is like what chapter is this problem coming from? Just looking at number 8, this question 8, you can see that this is a hypothesis test, right? And it's a one sample hypothesis test because you only see one mu. You don't see mu1, mu2, right? You just see one mu. So this is a chapter 9 problem. When I did SI, I know a lot of students were struggling with trying to figure out what kind of problem is this? How do I know what I'm supposed to do? Well, this is one way to look or figure it out, is to just look at what's the first question asking you. Null and alternative hypothesis, that's chapter 9 or 10, but then look at what is in the answer. Do you have mu1, mu2? If you see mu1 and mu2, that means it's a chapter 10 problem. If you just see mu1 or just a mu, one mu, that's a chapter 9 problem. Okay. The first thing I like to do when I do these problems is write out everything that is given to you. So just reading through this, what do we have? We have, let's just start from here. We have a sample of 60. So I'm going to go right here, just put N 60. What else do we have? We have X bar of 3,500. So let's do X bar 3,000, X bar 3,500. We have a sample standard deviation. So that's significant right here. Sample standard deviation. Like the most important thing with these problems is identifying if you have sample standard deviation or population standard deviation, because that determines what you do. But we have sample. Okay, so sample standard deviation 600. All right. Okay, so those are like the main things that we have. And let's just look at this last part right here, which is going to help us in figuring out number 8, which is this so right here, more than 3,000 texts per month. So I think I said this in a previous video, but typically in these problems, you are given the alternative hypothesis. So right here, we are trying to test, it says if on average, there more than 3,000 texts are being sent by women. So that means our alternative, HA, is going to be mu is greater than, right? Because more than, greater than, and 3,000. That means our null hypothesis, H0, is going to be mu is less than or equal to. Our null always has equals in it. So less than or equal to, and it's the opposite of your alternative. So less than or equal to 3,000. Okay. And I'm just going to look really quickly at what these questions are asking. You can see that in this problem, we're doing the p-value approach. So that's what we need to do. When doing the p-value approach, there are 2 numbers that we are going to be comparing to each other. Those 2 numbers are the p-value, and the alpha. Okay. So whenever we do the p-value approach, you're going to be comparing the p-value to alpha. I'm just going to put this as a side note right here. Whenever you're doing the critical value approach, I'll just put this like all the way to the side, so it's not. If you're doing the critical value approach, the 2 numbers that you're going to be comparing are the critical value and the test statistic. Okay. All right. But let's go here and let's get started on what we need to do. Okay. So we've already determined our null and alternative hypothesis. That's great. Let's figure out which one of these cases we are dealing with. Is it this one, or this one? Well, you can tell that because our alternative is greater than, we are looking at this case right here. I like to call these cases. So we're looking at this case right here. The next thing we need to pay attention to is our test statistic. We always need our test statistic. So I said that in the critical value approach, you're going to compare the critical value to the test statistic. If you're doing the p-value approach, to get the p-value, you need the test statistic. The test statistic is used in the p-value in the calculation. So I'm just going to move this here and let's calculate the test statistic. That's something that we need. So test statistic stat. What's the formula for test statistic? It's right here. So x bar minus value divided by standard deviation divided by square root of n. If you guys recall, this right here, standard deviation divided by square root of n, is your standard error. Okay. So to get our test statistic, we're going to take our x bar value, which we have right here. We're going to subtract out this value, which is this right here, 3,000, and we're going to divide it by the standard of error. To make our formula a little bit nicer when doing the test statistic, let's calculate standard error first. Since standard error is used, this is standard error. So standard deviation divided by square root of n. What's our standard deviation? That's 600 divided by square root of n. That's 60. So we're going to do that. And there we go. That's our standard error. Now we can calculate our test statistic. We said it's x bar minus value divided by standard error. So x bar, make sure you have the parentheses in the right place. So open parentheses, 3,500 minus 3,000 divided by your standard of error. And there we go. That's our test statistic. Okay. And since we're doing the p-value approach, this first page is for the critical value. I still like to use this to determine what case we use. Okay, let's move down here. Do we have a two-tailed test, a right-tailed test, or a left-tailed test? So we determined here that we have a right-tailed test, right? Because right here, greater than usually means it's a right, well, greater than means it's a right-tailed test. That's it. So we have a right-tailed test. So we're dealing with this right here. Now, remember how I said we have to pay attention to whether we have population standard deviation or sample standard deviation? Here's where that comes in. This formula right here will be used if we have population standard deviation. But since in our problem we have sample standard deviation, we are going to be using this formula. So when population standard deviation is not known, also meaning if we have sample standard deviation, this is what we're using. So we're going to be doing 1 minus t dot dist, test statistic, our degrees of freedom, which is n minus 1, comma 1. So let's do that. This is going to give us our p-value. So it's equals 1 minus t dot dist. Our x is our test statistic. Our degrees of freedom is n minus 1. And we just do 1 or true. And there's our answer. Now, the two values that we're comparing when determining if we reject or do not reject our when we reject or do not reject our null hypothesis is the p-value and alpha. So we have our p-value right here. In this problem, we are given our alpha, so this right here, alpha of 0.01, and then we compare the two. Just so you guys know, when you see this e of negative 0.8, that means that you're going to have to go back 8 decimal places. So in other words, this is a really small number. It's going to be 0.00000 whatever, and it goes on. So this means this is like a 0. So 0 is less than 0.01, right? And this is how we determine if we reject or do not reject. So since our p is less than our alpha, or our alpha is greater than our p, same thing, it means we reject. So our answer here is reject. So you can see that I didn't go and start doing these problems. I just know the whole process for doing these problems, and I like to just do it on my own. I like to do this whole entire process without really looking at the question. Well, I like to look at the question to determine, am I doing the p-value approach or critical value approach or both? But after that, I just go to the side and I just do the whole entire process, because now I can go back and look at the question, and it's very easy to start solving these questions because we already determined this. Our answer is B, right? So I can just highlight that. Our standard error, I put that right here, so 77.45. So the answer here would be this one. Test statistic, 6.45. There we go. P-value, that's basically 0, we said, so that would be our answer. And we said that we reject because our p-value is less than alpha. So our p is less than alpha. And that's why we reject. So that'd be our answer. And that's how you do this question. It's not too bad once you get the hang of it. You just have to do a lot of practice with these problems.